Okay, so we have question 8. It says a farmer bought a tractor for 980,000. The value of the tractor depreciates annually at a rate of 9.8% per annum on the reducing balance method. Calculate the book value of the tractor after 7 years. So this tractor here is depreciating annually at a rate of 9.2% per annum on the reducing balance method. So we must calculate the book value. What is the book value? This is the amount that it will now be selling the tractor for after those 7 years, after it has went that depreciation, right? So now the reducing balance method is this one. It makes use of the simple interest, just of the compound interest, meant to say, just now it has a minus sign, right? And then the straight line method makes use of the simple interest, just now it has the negative sign. So which one are we supposed to use? We are supposed to use this one. This is the reducing balance method. Then we just go ahead and substitute. Our P here is the present value, the amount that is spent on the tractor 7 years ago. So 980,000, and then 1 minus the I, it's that interest rate, so we are given 9.2%, but we know we have to write it as over 100, and then that will give us 0.092. So here we substitute 0.092, and then the number of years we write them as they are, because remember this tractor is depreciating annually, so the N here stands for the number of years, so we write 7. Having to punch all that in your calculator, you have a 498,685.82. So after 7 years, this is the value of the tractor, right? So this is what the farmer will be selling the tractor for. Then 8.2 says how many years will it take for an amount of 75,000 to accrue, right? To accrue means to grow. Right, so how many years will it take for an amount of 75,000 to grow to 116,253.50 in an account earning interest of 6.8% per annum compounded quarterly? So here we are told compounded quarterly. So here let's understand the situation. We can see that the 75,000 here is a lump sum, right? So this is just money that you put into an account, a savings account that earns interest, and then you just leave it there to grow, right? And then it grows to that amount. No fixed deposits, no regular payments. You just put your money in the savings account with interest, and then it grows to that. Right, so now we want to check how many years will it take for that 75,000 to grow to 116,253.50. So we make use of the compound formula. And this is 1 plus I, and then to the exponent of n, right? So the accumulated amount is that 116,253.50. and then is equals to P, our principal amount. So the money that we put into the account was 75,000, right? And then here we have 1 plus the interest that we are given there is 6.8%. So what do we do with that 6.8 divided by 100? We have 0.068, and then there we go, 0.068, and then over quarterly. Remember how many quarters are in a year? That's 4, so we put over 4 here. And then having to calculate the number of years, we know that here would be taking the number of years multiplied by the quarters, so we have 4 times n, right? So having to calculate this, we know that if we are looking for n here, we'll have to use to make use of the log rules, right? So we go for n is equals to log. Then a quick way to go about this is just take this one, make it the subject of the formula, say log, and then make this one, this whole thing here in the bracket a base. Then that's 1 plus 0.068 over 4, and then you take this 116,253.50 and then divide it to this principal amount here. So that's 75,000, right? Then if you want to just have it in a formula, that's log, and then here you'll be taking the principal amount, you'll be taking this, so you'll be taking the 1 plus I, and then you say A over P. So in terms of a formula, that's how you have it. Then if you punch all that in your calculator, you punch all this in your calculator, it gives you something like 25.999, which we can write as 26 rounded to a whole number. Then divide by 4. My n is now, so remember this 26, that will be in quarters. So but then we want it in years, so we divide by 4, and then we have 6.5 years. Awesome. 8.3 says Thabo wanted to save 450,000 as a deposit to buy a house on 30 June 2018. He deposited a fixed amount. So let's read there. They say he deposited a fixed amount of money at the end of every month into an account earning interest of 8.35% per annum compounded monthly. His first deposit was made on 31 July 2013 and his 60th deposit on 30 June 2018. So if you can find the difference in years, you can see that it's 5 years, and between 5 years we have 60 months, right? Then calculate the amount he deposited monthly. So what are we looking for here? We are looking for the X amount. But what formula must we use? Here is a hint. Thabo wanted to save 450,000. What did he want to do? Save, right? So whenever we see the word save or invest, we know that we must apply future value. Then having to calculate this one, we make use of the formula future value x 1 plus I to the exponent of n minus 1, and then all over I, right? Then the future value that we are looking for, remember Thabo wants to save 450,000. The 450,000 is not here yet, so it's the money that he hopes to accumulate in the future, right? So that's where we get to choose the future value, because the money is not there yet. It is money that he plans to save, right? Then this is x, we are looking for x, and then 1 plus the interest. If we calculate the interest there, it will give us 0.0835, the interest rate, and then over 12, and then how the number of payments that it makes is 60, and then minus 1 over now 0.0835 over 12. Now a quick way to get this x will just be to cross multiply here and divide by the whole of this. So we have x is equals to 450,000 and then multiply by 0.0835 over 12, and then you just take all of this in the numerator. So remember, you have made x the subject of the formula. Then you take all that, that's 1 plus 0.0835 over 12 to the exponent of 60 minus 1, and then punch all that in your calculator. Then with this method, you are just avoiding to have a lot of rounded off answers that might affect your final answer here. Then you just punch all that and then it gives you straight the answer. So there you go, 6,068.69. Okay, 8.3.2 now says Thabo bought a house. So the same Thabo now bought a house costing 1,500,000 and used his savings. So now after saving this money 450,000, he then used it as a deposit, as it is stated here that he wanted to save 450,000 as a deposit to buy a house. Now he has bought the house that cost 1,500,000 and used his savings as the deposit. He obtained a home loan for the balance of the purchase price. So he didn't acquire a loan for this 1,500,000. Instead, he was able to pay the down payment himself by saving for those 5 years, for that 5 years, or those for that 60 months. And then now he obtained a home loan for the balance of the purchase price at an interest of 12% per annum compounded monthly over 25 years. He made his first monthly installment of 11,058.85, right, towards the loan on 31 July 2018, right? Then A says, what will the balance outstanding on the loan be on 30 June 2039, which is 21 years after the loan was granted? So now we are looking for the outstanding balance. What is the outstanding balance? This is the amount that is left off to pay off the loan, right? So this is the money left to pay off the loan. Now he's starting at T0 here, and then At T21, we want to find out using our number line what is 21 years in months, right? So this is 252, and then obviously 25 years in months, that's 300 months. So now the outstanding balance we are looking for is here, right? But then the outstanding balance speaks for this amount here, the amount that will be remaining for this period here. So what will be the amount that will be left with in order to close off the loan, right? In order to pay off all the rest of the amount of the loan, right? So this is what we are trying to calculate here. But then since we are working on loans, we know that the formula that we have to apply here is present value. Now to calculate the outstanding balance, OB, we make use of the present value formula, which goes x 1 minus 1 plus I to the exponent of negative n, and then over I. Now remember, we are told of a new monthly payment, right? He's now paying off the loan. So now paying off the loan, he deposits a bigger amount every month. So 0.85, and then we have 1. So here we have this I, and then 1 plus the interest. Now they gave us 12%, which we know we must say 12 over 100, it gives us 0.12. So that's 0.12 over 12 because it's compounded monthly. And then what is it that I'm going to substitute here on n? So we are not looking for this 252 here. We're not going to be substituting 252. Instead, we'll be substituting the remaining months in order to close off the balance. So now we're going to say 300 minus 252, which will now leave us at 48 months. So he's left with only 48 months, which is 4 years to pay off the loan, right? So from 21 to 24, 21 to 25 years, that's 4 years in between. So now we substitute negative 48 here, right? So that's 48 over the interest is 0.12 over 12. Now you just go ahead and punch all that in your calculator. Your present value will now be 419,948.32, right? So therefore that will be the outstanding balance. So that's 419,948.32. Awesome. Now let's look at B. It says calculate the interest Thabo will have paid over the first 21 years of the loan, right? Calculate the interest Thabo will have paid over the first 21 years of the loan. Now to calculate the interest, we make use of the formula that goes interest is equals to nx minus the present value. So this one you only use it when you are calculating the interest for loans. It is not there in the back of your formula sheet, so you have to note it. Interest is equals to nx minus PV. So the n here is the period, and then the x, obviously, these are the monthly payments that we make, then minus the present value. But then the problem with this one is that the present value we are working with here is for 21 years. And this question here for A, we were not calculating the present value for 21 years. Instead, we were calculating the outstanding balance for the remaining 4 years before the loan comes to completion, or before the loan period comes to completion, right? So now, having to deal with that, we can now use the number line in order to find the present value for 21 years. Now 21 years, you will remember that in months we said it's 252, and then the 25 years is T300. Now in the previous question A, we calculated this amount, and then we found 419,948.32, right? 0.32. So we calculated that amount to be this, but then we know the total amount to be paid here. So the value of the value of the loan was 1,050,000. Now you might ask, where do I take this 1,050,000? Remember, the house that Thabo bought cost 1,500,000, but he had already made a down payment of 450,000, right? So that means the loan amount is now 1,000. and 50,000. Remember, they said he took the loan for the remaining balance, right? So this is what he asked from the bank, the 1,050,000 that he now needs to pay off. But remember, the amount here, this is the amount that it was left to pay off for the 4 years that was remaining. Now, what we are looking for here is the amount that he paid over the 21 years, the amount that he paid over this 252 months, right? 21 years. So let's call this Y. If we wanted to calculate the value here, Y, now you can see that do is take this 1,050,000 and then subtract the outstanding balance, which is 419, and then 948.32. Right. If you now subtract this, you will get the money that he has to pay over this 21 years. Right. Which now subtracting that, we get 630,051. Right. 0.68. So this is the present value amount for 21 years. Right. So this is the present value amount for 21 years, which will then substitute where? Here. Right. But then we are not done. Let's calculate. Now we want the total that he pays here. So we are done with this one, the PV. But now we want the total that he pays. So this is, let's say, total paid. This will be the period, which is number of years multiplied by 12. So that's for 21 years, then multiply it by 12. Then we have to multiply all that by the amount that he puts in every month there. So the monthly installments that he pays, which is 11,058.85. Now, if we multiply all this, we get that the value is 2,786,830.2. Right. So having to pay all the interest, because remember the amount here is calculated with interest. Now when he pays over the 21 years, he would have paid 2,786,830.2. Right. So but then in actual fact, if there was no interest charge, this was the amount that he would have paid over the 21 years. Now we want to see the interest, right? What is the interest? What is the amount that he pays extra? So we now say interest is equal to NX minus PV. Now we have that 2,786,830.2 minus the present value, which we calculated to be 630,051.68. Now the interest is now 2,156,778.52. So over those 21 years, this is the interest that it will pay for only just taking 1,050,000 rand to buy a house.